scientist. I currently work as a research assistant in the University of Cambridge at the MacDonald Institute for Archaeological Research, and I look at objects and how we can understand how they were made, and I use scientific techniques to do this. However, before I was at Cambridge, I did a master's in forensic archaeology and anthropology, specialising in paleopathology, which is how disease affects us in the past, the historic study of disease, the study of historic disease, sorry. And I figured, as I'm currently literally right now writing an article on smallpox, um, why not talk to you about it? And we can do it live, it'll be saved on my channel, and then you can ask questions in the chat or in the comments, and we can have a whole conversation about how disease impacts the skeleton. And I'm gonna start from the beginning, which is how disease can possibly impact the human skeleton. And I'm not talking about specific bone disorders here, I mean actually illnesses that you would have in your everyday life, or at least that they had in their everyday lives in the past. And some of these illnesses, such as tuberculosis and smallpox, can change the skeleton. And this is because the human skeleton undergoes changes during life anyway, in response to natural growth and development, mechanical forces, and physiological influences such as illness and nutrition. And these skeletal changes occur due to the bone's dynamic nature and plasticity. And essentially what this means is bones naturally model and remodel throughout life. And this process is continuous and is vital for growth, it's vital for healing and general preservation of bones during mechanical use. And so during periods of illness, or in response to trauma as well, the natural homeostasis of this bone cell activity can change, and this activity is responsible for bone remodeling. And when you're ill or when you have an illness, it can be disturbed. If this process isn't going how it should be, you can have irregular and abnormal bone formation in places where you wouldn't necessarily expect it. You could have bone destruction, and in children, this bone turnover rate is faster as well. And this is normal in children, this is how they grow. It's to accommodate for appositional and lengthways growth in their bones. And so in children, skeletal evidence for illness may actually appear faster than in adults. And actually, some illnesses, definitely smallpox, and also tuberculosis is faster in children. Definitely smallpox, it actually only impacts the skeleton if they suffer from smallpox during childhood. And this is because once you finish growing, your bones at the metaphysis, I wish I could put a picture on the screen right now, but it's like the neck part of the bone. If you imagine a long bone, it flares at the top and it flares at the bottom. The metaphysis is where that flare is. This has what's called a physial plate, and you have an epiphysis that joins. So if you think of your femur, it has this big ball at the top. Once they join, they're fused. So before fusion, the blood flow goes into the metaphysis. There's a lot more blood flow in this area, and they're two separate bits. Once they fuse, the plate no longer exists, so it doesn't spread. And there are a lot of ways that the bone can be affected, and most of these are non-specific. So whilst they might be recognisable in themselves as a condition, they're not necessarily representative of a specific disease or illness. And so we have to look at the distribution of these changes across the skeleton in order to give potential differential diagnoses. And so one of these is osteomyelitis. You might have heard of osteomyelitis. It is a general term referring to any bone or bone marrow infection that results in inflammation and destruction of bone. And it can be limited to the bone marrow, or it can then stimulate subsequent infections as well on the outer layers of the bone, which is the periosteum, for example, which is like the outer layer. If you have a cross-section of bone, there's a very thin layer around the outside called the periosteum. And the bone marrow cavity is the very center of the bone. And in 90% of cases, this is caused by bacteria entering that bone marrow cavity. And the responsible bacterium is Staphylococcus aureus. There's three general characteristics of osteomyelitis. So you have the presence of cloaca, which, to be very blunt about it, is basically a channel for pus, nice, to leave the infected area. You have sequestration, which is where you have bone destruction, which leaves a little island of bone in the center, and involucrum, which is new bone formation in a sort of sheathing or encasing effect around the long bone, and this is in the periosteum. So that is the outer layer of the bone. And these cloaca lesions are through the bone's cortex, so they go right through the thick, hard bit of the bone. And basically, because this is a non-specific type of infection, it isn't clearly linked to any condition in particular. However, a lot of illnesses that do affect the bone, will include osteomyelitis. It can also be a secondary impact of diseases as well. So I'll mention this later when I'm talking about smallpox. You could have an initial infection that is viral, and then it leads to bacterial infections, probably because the immune system is already up in arms, and they're already sick, and it leaves the way for further infection. Can bacterial diseases affect bone structures too? They certainly affect the skeleton, yes, but it depends which disease. Not all of them will, but for example, tuberculosis is Mycobacterium tuberculosis, and this actually involves the skeleton in about 3 to 5% of those infected and untreated. Again, this is it will always be at least more severe in children, just because of the way their bones form more rapidly. But the key skeletal indicators of TB infection are destructive lesions in the lower vertebrae. So they can be anything from, like, they basically look like destructive nodules in the lower spine. So you have the lumbar vertebrae, the thoracic vertebrae, and then the cervical vertebrae. And in the lower vertebrae, in the lumbar, you can get these really pronounced destructive lesions. So they're like holes, essentially. And these can get so bad that you can end up with the collapse of the lower vertebrae, which is called kyphosis, which is basically when the spine bends anteriorly, and that would be extremely painful. And we can see this in archaeological skeletons because it is so pronounced and prominent in some cases. And off the top of my head, I think one of the Medicis had this, as in it's in documented sources, and they also portrayed it in Medici, in the Netflix TV show. I want to say it was Lorenzo Medici. So TB doesn't just affect the spine, because it is also a respiratory disease. It can also cause new bone formation on the rib surfaces, on the under surfaces of the ribs, and also just generally involve the joints. So it primarily targets the really spongy bone, which is trabecular bone. You get a lot of this in the vertebrae, and you get this in the metaphysis of bones. So the bones that it targets the most are the spine and the ribs, but then after that you have the hips and the knees after that, but the hips is going to be most frequent in terms of which limbs and which long bone areas are involved. So yeah, the lower limbs are more frequently involved. hips, knees, and then in younger individuals, because, as I keep saying, because of bone turnover, and these children's skeletons are more plastic than us grown-ups, and this basically means that more aspects of the skeleton can be affected. So they could also get involvement in the elbows, the ribs, the fingers, and the toes. And in the fingers and the toes, it can lead to what's called dactylitis, which means that you get premature fusion of the epiphyses in these finger bones. And you can end up with digits that are much shorter than they should be. Basically, your hands don't necessarily look symmetrical anymore. You can end up with different length fingers and bits of destroyed bone. And I'm gonna link all the references for this in the description, but they won't be in the description until after the live ends. But you can come back and then get the references afterwards. Okay, what questions? Can diseases like measles or influenza also leave detectable signs on bones? So viruses are really understudied when it comes to how they impact the skeleton. It's mostly bacteria that, at least clinically, is most research about how it impacts the skeleton. But as far as I'm aware, influenza doesn't have any specific skeletal changes associated with it. Measles does, but only in, or is that rubella? I'm gonna have to go. I think it does, but I think it is just potentially in utero. Let me see. Obviously, I don't know everything about every disease. So measles. Can you get arthritis and Paget's disease potentially? Is Paget's measles? I don't know. We'll come back to that. But can DNA analysis from bone remnants confirm smallpox? This has definitely been done for. This has definitely been done. Yes, full stop. Just not much. So there are a few papers. One is by lead author is Mullerman. I've definitely butchered that pronunciation, but that is an article that came out in 2020 about sequencing smallpox in archaeological skeletons. Another one is by Anna Duggan. That one's a really interesting one. So this is skeletal and also mummified remains. But the answer is yes. However, it's a little bit limited, sorry, because obviously the disease breaks down. The DNA breaks down a lot, and also you should only be finding it in the bones and in the teeth generally if that individual had active infection at the time of death, because it will need to have been in the bloodstream. However, there are some studies that have done sequenced active bone lesions, so where there's evidence of that lesion that is related to, say, tuberculosis is still forming and remodeling. It's been sequenced from that, as well as calculus, or yes, I think calculus on the teeth as well. But again, that is completely off the top of my head, so go and Google that, because it's actually a really interesting topic which is constantly like changing. Smallpox is my main area of research. I did publish a guidance to the bony lesions of smallpox in the International Journal of Paleopathology, and I'm writing a sort of follow-up to that right now, which is why I'm doing this live stream. But basically, some pox viruses, so orthopox viruses, can cause lifelong skeletal changes, and These are fairly understudied, or at least currently in the clinical work, because smallpox is eradicated. However, we obviously have mpox now, and mpox was a massive deal in the last few years, and given climate change and migration, both of animals and of people, we might expect more zoonotic diseases to come into the human sphere. And if they are orthopox viruses, which smallpox not originally, like the ancestor to smallpox would have been an animal disease. At the minute, it's thought that it could be pteropox or camelpox, or an ancestor of those two. And so at one point, it was a spillover in terms of it affected humans. However, VARV, the variola virus, which is what causes smallpox, is a human-specific infecting orthopox virus. So it is adapted specifically to infect humans. And so the effects may well be different, but for example, vaccinia virus, which is the genetically created virus, as far as I'm aware, which was used in the early vaccinations, or maybe it's a close relative. Cowpox is not the same thing, but it is another orthopox virus. There is evidence of this vaccinia anyway, like actively affecting the skeleton at the site of where there's swelling in a long bone, which is very similar to what we see in smallpox. So it is possible that things like mpox can have the same sort of effect. And there are some papers that have already come out saying that there is bone involvement, and this is generally in more immunocompromised patients. There's not so much yet about mpox in children in terms of the long-term impacts, but I think we may start to see more things come out. And smallpox on the skeleton is generally recognized from elbow involvement. So after you have the characteristic rash and the fever with smallpox, once those poxes, essentially the pustules, start to fall off, you can start to have swelling and inflammation of the elbows, the knees, the ankles. And this is written in the clinical literature. And essentially, what is happening there when it's all swollen is that the metaphyses and the epiphyses of these long bones have been involved in some way. So again, it's not fully studied because it hasn't been clinically relevant for some time, but it's likely that there's a few pathways. So you have direct infection from the smallpox virus during viremia, which is when it's in the bloodstream. But then also you can get secondary bacterial involvement at the joints as well. And this is often what happens in the really severe cases. So it's basically joint and long bone inflammation followed by bone destruction and remodeling. And this starts about 1 to 4 weeks after smallpox begins. Most prominently affects the elbows, then the knees, the wrists, and the ankles. And this is on both sides of the skeleton. So again, this is something which is unique to not just smallpox, but it is a unique feature of smallpox generally. And that's that it affects the skeleton bilaterally. So if we have one elbow affected, generally you also see the other one affected too. And they don't just go away, these changes, after, say, a month. It's not certain exactly how long it takes for them to remodel, but because our bones are remodeling, and these are children, again, so if the child has survived smallpox, they may then end up with these secondary changes, and if they survive with this bone infection and bone inflammation, this can last a lifetime. These can be lifelong visible limb differences caused initially by a smallpox infection. And clinically, this is still being recorded in India, most prominently from outbreaks in the 1970s, just before eradication in 1980. And essentially, it's 60-ish-year-old individuals being admitted to hospital with some kind of joint complaint, whether they have pain or limited mobility, and they're not going in as I have this issue with my elbow from smallpox. It's so far has always been unrelated. Then when they get into hospital, the link is made to a childhood smallpox infection. And this is really interesting for archaeology because it's telling us that we shouldn't be just thinking about this illness that may have happened based on the evidence on the skeleton in its own like single unique capacity. We need to be thinking about how that illness and maybe associated problems caused by it can then impact the individual's life for the entire time that they then survived afterwards. So if we have an adult that has these typical longer term bone changes of smallpox, they've lived with that. And what was their lived experience like as a consequence? Basically, I'm just dumping on you because this is my main area of interest and research right now. Basically, it's really important as well that we keep learning about these changes because more people keep turning up at hospitals with them. And while smallpox is eradicated, it still exists in laboratories in, I want to say, the US and Russia, from leftover from the Cold War, when there was potential threat of like biological warfare, essentially. And now we're not vaccinated against smallpox, at least not in the UK, because there was the successful global eradication campaign. It meant nobody needed it anymore. We didn't need that herd immunity caused by people having the vaccine. So now we have a whole new generation of people with no smallpox vaccination. And so if it was somehow reintroduced, or if another equally human infecting orthopox virus was introduced, we have no defense against it. And smallpox was extremely virulent. So in populations where it wasn't endemic, so basically when it was new, it had a really high mortality rate, which is not something that we want, obviously. Another illness, this is bacteria again, another illness is syphilis. That also affects the skeleton. It's a form of treponemal disease, and the changes in this happen more often than in smallpox. So you have 10 to 20% of people with the disease getting these skeletal changes. And with it being syphilis, it is an STD, so it's not a child-specific it's not a child-specific skeleton involving disease, this one. This also changes the skeleton in adults. But it can affect children congenitally, so you can get congenital syphilis, and this is where the disease is passed from mother to child in the womb. And in the non-congenital syphilis, you get destructive cranial lesions, and these are called gummatous lesions. These are pretty diagnostic of syphilis, but other skeletal changes can include the involvement of the nose and the upper jaw, inflammation of the long bones, again, and the joints, and also widespread periosteal new bone formation. So just general new bone formation where it shouldn't be forming across the skeleton. This new bone formation occurs when that normal bone cell formation is disrupted. So when that normal homeostasis of the balance between cell producing and cell destroying cells are present at the same time. So basically, remember, it's a disruption of the natural homeostasis of bone cell activity. In treponemal disease, the new bone formation is most often found on the tibia, and this can result in a bowed and really thickened appearance, and it can be super prominent. It's called saber tibia, if you do want to Google that and find images. It might look distressing, I'm not gonna lie, so please just do that at your own risk. But it is, if you've got saber tibia and the gummatous lesions on the skull, you might be looking at syphilis in the oncological record, for example. So this is the most common, but you can also get upper limb involvement, and there are other types of treponemal disease like yours, for example, which is a tropical treponemal disease which affects the upper limbs more. So that one also has elbow involvement, for example. Leprosy is another one, and maybe one of the most famous diseases that impact the skeleton because of the attitudes towards it in the past and still today, like ostracizing people, because leprosy is a very visible disease. It really impacts the face as well, and so it can not only be disfiguring in terms of whether others affect the skeleton, it also affects exactly how you look, and your face and your eyes and your mouth and your nose are who you are, really. And in the past, I think that would have had a huge impact, and it did. It had a huge impact. We know there were leprosaria where people were sent to live separately to everyone else. And people are still ostracized today in certain parts of the world where leprosy is more prevalent. So 15 to 20 new cases, actually, of leprosy are diagnosed every year, and this is in the UK alone. So whilst you might think it's a historic disease, it is not necessarily. It is still around. But the skeleton is reported to be involved in 5% of individuals, at least those who are hospitalized, so there might be more. But this is just based on individuals who went to hospital with the bone changes. And the main one is rhinomaxillary syndrome. So this is where there's inflammation and destruction of the nose and the upper jaw, so like this sort of area of the face. And also bone formation around the sinuses. And basically, it's super, super destructive. So you can have essentially a hole in the skull at the front. But there are other skeletal changes, and these are caused by the spread of infection from soft tissue to the skeleton. For example, destructive lesions, which are called lepromas, and some secondary changes as well, which aren't caused by direct infection but can still be severe. Excuse me. And these changes include bone loss and changes to mobility in the hands and in the feet. And it all stems from nerve damage, which is like, if you imagine, again, the lived experience of these diseases, not only is it affecting a very visible part of the body, you're also getting nerve damage and like skin lesions and skin trauma. And because there's nerve damage, this can basically mean that you have more trauma to those areas and that you don't realize necessarily, which can then get infected if it's untreated, and that's how it spreads to the skeleton. And those are just a few illnesses that can affect the skeleton. There are obviously caveats to this. We can't just go and look at a skeleton and say immediately that has this disease. We have to look at it for a while, and we don't necessarily, or ever, to be honest, just say that's got TB, that's got smallpox. What we would do is write down everything that we see, like a full osteological review, essentially, of an individual, of the skeleton, so that in future, anybody else who looks at it should be able to also come to the same conclusion, or at least have the exact same evidence that the first person who did the review has, to then come to their own conclusion. So we want a full sort of map of exactly where everything is. If it's non-specific, what type of non-specific infection is it, and where on the skeleton is this focused? So a lot of these, for example, have a periosteal new bone formation, which is non-specific, because that is it's on all of them, basically. That's not linked to any condition in particular. But if it's in certain places, for example, like on the tibia, then we might have an idea as to what's going on. And archaeologists aren't doctors. We don't, well, some are actually, but we're not within a capacity to be able to diagnose an individual or to say they died from this. What we can do, and what we do is say these bone changes are consistent with XYZ diseases. So the most probable differential diagnoses are, and sometimes the media runs with that, and so we have a sort of duty to make sure that whatever we write is, I guess, open enough but backed by enough evidence that it makes sense. There's also what's called the osteological paradox, though. So this is a really critical dilemma that we face when we study disease in the past. And basically, because our bones remodel and they react to stress and illness and nutrition, like I mentioned, this does mean that obviously disease can affect the skeleton. But for it to actually get to the point where the disease has impacted the skeleton, they need to have had this condition for a while, because the bones don't just change immediately. This remodeling process takes time, and especially where lesions are super pronounced, there could have been a while that this individual was suffering with that illness. And yet, at the same time, if they've survived that long, then they must be strong enough to have survived that long. But they also maybe succumb to it. So if you have lesions that are active but also really pronounced, they're both a survivor and a non-survivor. And that's the paradox, essentially. For a disease to actually noticeably manifest, they must be severe enough to manifest, but also long term. But also a severe illness is also likely to kill more quickly. Yeah, so it means that those people that we see in the archaeological record are those that were robust enough to survive with a disease to incur the bone changes. So when we're looking at disease prevalence in the past, it's difficult to actually say what that prevalence is, because we don't know how many of these people who died with no bone changes also had that illness and just were not able to deal with it for long enough that it impacted the skeleton. And again, the reference for that will be in the description after the live ends. Now I'm just going to check there's any questions, because I will end this soon. But if anybody has any questions about disease on the skeleton, any specific diseases, or just archaeology generally, osteology, for people who just joined, my background is in archaeology, forensic anthropology, with a specialism in smallpox and how smallpox impacts the skeleton, but also generally disease and children as well, because they deserve to have their stories told. Children shouldn't be who we're finding in the archaeological record, but they are, really sadly. And so if we can learn something about their lives and what they brought to the world, then why not? Polio. Yeah, polio really does affect the skeleton, which is why those iron lungs existed. Yeah, and why we need to keep getting our vaccinations, because that is not an epidemic that we want to come back. Polio is not one that I have spent, it's not been on my radar quite as much as the others, but I think that's because, I don't know if it's more recent though. It's just not been on the radar at the sites that I've been at or in the samples that I've been working with. Oh yeah, it's not recent. It's old. So my bad. Any risk of smallpox from the samples you... Well, I hope not. I haven't got smallpox yet. No, I don't think so. So, for one, the DNA is not likely to survive. I'm not using recent samples. It's fairly old. And also, at least in the individual that I have, they don't appear to be active lesions either, which would suggest that they had smallpox and survived that infection. Hopefully. That's what I keep telling myself. There is a paper, I can't remember when it came out, but I'll find it and I'll put it in the description, that was talking about, I think it was textile, where they actually had smallpox DNA? Because smallpox DNA has been found in mummified remains. But as far as I'm aware, it has never caused an outbreak. I don't know, I'd still be careful. You don't want to tempt fate, right? I'm trying to find this article. Smallpox textile. Okay, so if you Google smallpox textile, the smallpox blanket controversy comes up. That's what I was talking about. I believe one was found. But this is also referring to the purposeful spreading of smallpox in the past by colonizers. But as far as I'm aware, it is one of these blankets. An investigation was carried out to establish the survival period of variola virus in relation to its importation into Great Britain in raw cotton. Also, maybe they're different cases. Okay. The results suggest that variola virus in scabs or seeds in tropical climates, e.g. at temperatures of 30 C to 40 C Celsius, is unlikely to survive for as long as 6 months. So if the period of storage of cotton were at least 6 months before shipment, the chances of a viable virus surviving would be very small. However, if it was at 20 to 25 degrees C, the experiments indicate that a few particles may survive for as long as 18 months. So if it's cold, then it survives for longer. Interesting. But yeah, I haven't got smallpox from the skeleton that I studied. That's the moral of that. Any more questions before I switch off? Because I actually need to write the paper on smallpox that I'm trying to write. And I keep obviously doing things that distract me, such as a live stream, which is fine. As a Canadian, I know nothing about that. Yeah, I mean, I didn't either until I was directly researching smallpox. It's a scary thing. Horrible. Okay, we don't have any more questions, so I'm going to call it there. Thank you so much for joining. This will be saved on my YouTube channel permanently, and I will put all the references into the description, so you can do your own research. I'm also going to turn this into a sort of Reels series as well, so there will be, I guess, a more polished version in YouTube Shorts, Reels, TikTok, etc., where there'll be visual aids as well. So if you are really interested in this sort of thing, then look out for those because they might be more helpful than just my ramblings. But I hope you enjoyed anyway. I enjoyed doing it, so maybe I'll do more like, I don't know, like, it's not even a lecture, is it? Sort of teaching, I guess, slash discussion, but it's fun. And I hope it was helpful, interesting in some way, shape, or form. Who knows? Yeah, thanks, guys. Bye. I hope you have a lovely Sunday evening.